This video is produced by the UCD Math Support Centre in conjunction with the UCD Access Centre. In this video, we will be looking at how to simplify expressions involving indices. So in the following example, we will let y be an element of R and y is not equal to 0. So we will simplify the following fraction. 2y cubed all squared multiplied by 3y to the power of minus 7 all over 6y. Before we start, it's important to note that the way we go through this is not necessarily the only way to attack this problem. The steps that we take in the order that we take them is not the only way to do this. So to do this, we'll look at this fraction line by line. So we'll take a look at the top line first, and we'll go across it term by term. So the top line consists of 2y cubed all squared and 3y to the power of minus 7. So let's just look at 2y cubed all squared first. So we can distribute the power of 2 across each element. So 2y cubed all squared will become 2 squared times y cubed squared. Next, 2 squared will become 4, and the y cubed all squared will become y to the power of 3 times 2, which will give us an answer of 4y to the power of 6. So the top line now reads 4y to the 6 times 3y to the minus 7. So can we simplify this any more and do any better? Well, thankfully we can. So when we're multiplying all of these together, we can multiply the like terms with the like terms. So the coefficients in front of the y, i.e. the 4 and the 3, can be multiplied together, as you can see here in this bracket. They become 4 times 3. And we'll multiply the y values together. So y to the power of 6 multiplied by y to the power of minus 7. So the 4 times 3 will give us 12. Y to the 6 times y to the 7 gives us y to the power of 6 minus 7. So when we have the same base and different powers, we can write it with the one base and add or subtract the powers accordingly. And 6 minus 7 is of course minus 1, so this leaves us with 12y to the power of minus 1. So in total what we've done so far is 2y cubed all squared times 3y to the power of minus 7 all over 6y has been whittled down to 12y to the power of minus 1 all over 6y. And what we can do is the 12 over the 6 can be simplified down because 6 goes into 12 2 times, meaning we can have a 2 outside multiplied by y to the power of minus 1 all over y. So we're nearly there. The last thing we have to do is see can we simplify this y to the power of minus 1 all over y. Well, y to the power of minus 1 over y can be written as y to the power of minus 1 multiplied by 1 over y. So when we're multiplying a fraction by a number, i.e. the number being y to the power of minus 1, that number just goes onto the top line. So we can just as easily take it off the top line and look at these as two separate terms. So from a previous video that deals with integer powers, y to the power of minus 1 is the same thing as 1 over y. So y to the power of minus 1 times 1 over y actually reads as 1 over y times 1 over y. Now we're multiplying two rational numbers together, so when we do that we multiply the top by the top and we multiply the bottom by the bottom and put them all as one fraction. So 1 over y times 1 over y will become 1 over y squared. So from 2 times y to the power of minus 1 over y, we end up with 2 times 1 over y squared, or 2 over y squared. again, the number goes onto the top of the fraction. So altogether what we've done is started with the mouthful expression of 2y cubed all squared times 3y to the power of minus 7 all over 6y. We have taken this line by line and in each line, term by term, to simplify it as much as we can, and this whole fraction actually only reads as 2 over y squared.